Welcome. Today we shall be learning some more processes which are used for the recovery of the sulfur. This is in continuation with the previous lecture on the sulfur recovery. In this particular lecture, we shall be learning about these four processes for the sulfur recovery. First, we come to the tail gas treatment. This is used to remove the last remaining sulfur containing species to meet the environmental regulations after sulfur recovery, and these species are these carbonyl sulfide, carbon disulfide, methyl mercaptan and carbon monoxide, H2S, etc. So, all these are the species which are also recovered during the tail gas treatment, and this uses an amine system for the sulfur recovery. This is the process description here. So, this constitutes basically three steps. First step is the reducing gas generation to obtain H2 and CO and the tail gas preheat. So, these hydrogen and carbon monoxide are the reducing gas which are generated here, and in this what is done that we heat the tail gas to about 290 to 340 degrees centigrade by a reducing gas generator which is shown over here. So, this natural gas this is coming and with the combustion air is also inputted. This is the reducing gas generator. So, after this we carry out the hydrogenation and hydrolysis of the sulfur dioxide and other sulfur species to obtain H2S. So, here we show this hydrogenation is being done, and in this the reactions are like this. Hydrogenation we call when sulfur dioxide and sulfur elemental sulfur are converted to H2S using hydrogen. So, that is why the name hydrogenation. So, these are the two equations by which the sulfur dioxide is converted to H2S and elemental sulfur is converted to the H2S, and this delta H represents the heat of the reaction. And then we have hydrolysis, in which this COS, that is the carbonyl sulfide and carbon disulfide are converted to H2S using water, using this particular reaction with some heat of reaction. So, this is the second step. After this, the gas is cooled and sulfur is recovered by amine in this particular thing, in this particular column, and in this column we find that maybe they are using some kind of alkali, that is NaOH, and in this particular we also go for a second stage of removal of this sulfur. So, these are two ways we are removing this H2S to H2, because H2S is acidic, we are using some alkali, amine or the NaOH to recover it. And then what we find that in this particular equipment tower, we are getting back the amine. So, we are cooling the reduced tail gas to about 30 to 40 degrees centigrade, and when we reduce the tail gas temperature, we find that water vapor condenses out and is removed, and removal of H2S and some CO2 from the cooled gas by absorbing with NaOH and amine, and then recycling the H2S and CO2 to sulfur recovery unit for further processing of the sulfur. So, here we are, this treated gas is taken to atmosphere or incinerator, and here we are getting this acid gas recycle, and this is going to the sulfur recovery unit. So, this is the overall process description for the tail gas treatment. Now, we come to the redox process. The name redox means reduction and oxidation. So, both reduction and oxidation are carried out in this particular process. It is a liquid phase process, and what we do that first we remove the H2S by scrubbing with some mild alkali solution in this thing, and these Venturi sprays are used for this kind of removal scrubbing, that is it is spraying the liquid from the tower. So, that is why we are using Venturi sprays, and then this is absorbing, absorption is going on in this, and then this H2S is removed selectively by some chemical absorption using a dilute aqueous solution of iron or vanadium. So, in this we are reacting this H2S with the iron or vanadium aqueous solution, and then we find that we are going for the sulfur recovery, and the catalyst oxidizes the H2S to elemental sulfur. The reduced catalyst is regenerated by contacting with the air in the oxidizer. So, we find that first it is reduced and then it is oxidized, and the removal of the sulfur from the solution by floating or settling. So, ultimately we find that we are able to remove the sulfur by converting the H2S to elemental sulfur. And here we are recycling the rich liquor after regeneration in this particular thing by heating with the air. So, that is how we are carrying out this redox process. So, here we find that the H2S containing gas comes after removal of H2S. This is the treated off gas which is now meeting the environmental regulation quality. This redox process can be used for small or dilute H2S streams to recover sulfur from the acid gas. That in this case we are recovering sulfur directly, and this can be used in place of acid gas removal process if the H2S concentration is less. And these are the two variants of this redox process, LOCAT and sulfurex. We shall not be covering these two processes here, and it is possible to recover about 99% of the sulfur from the tail gas. Next we come to the Scott process. It is used to reduce the sulfur dioxide in the Claus plant back to the H2S, as we learnt earlier about this Claus process. And here it consists of two steps. One is the catalytic hydrogenation or hydrolysis, and another is the scrubbing with amine. And the amine treating is used to remove the H2S, which is recycled back to the Claus process conversion to the elemental sulfur, and it can produce a gas exit that contains very low amount of sulfur in the range of 10 to 400 ppm V, and it increases the sulfur recovery up to 99.7%. That is, Scott process is a very effective process. And here is the process description. It also entails many steps. First is that the feed off gas is a Claus tail gas. It is coming. We are mixing with the reducing gas here. This reducing gas consists of the hydrogen or a mixture of hydrogen and carbon monoxide, and these are all mixed with this Claus tail gas, and also we are putting the air, and these are taken to a furnace and they are heated up to about 302 degree centigrade, and then it is catalytically reduced to get the H2S from SO2, CS2 and COS. So, in the Claus catalytic reactor here we are able to get the H2S and water from these components, and then what happens that the cooling of the gas is done using a waste heat exchanger. So that in the this heat exchanger we are putting water, and whatever heat is generated during the reaction is used to convert this water into the low pressure steam, and this low pressure steam can be used for the regeneration purpose, and the gas is further cooled to about 38 degree centigrade in a quench tower. So, gas goes in the quench tower. So, it is further cooled before it is sent to the absorber, because it is cooled because the absorption is favored at low temperature. So, the gas has to be cooled, and this cooling is achieved by recycling with water in the quench tower. And after this, what we find after this, it is sent to absorber. In the absorber we are using some kind of amine to take out this carbon dioxide and the H2S, and exit gas from top of the absorber contains about 10 to 400 ppm of H2S. That is, this exit gas is about 10 to 400 ppm of the H2S, and which is sent to incinerator, and the regeneration of the rich amine by the steam stripping in the regeneration column. So, in this regeneration column we are whatever rich amine is coming, that is taken here, and from this we are getting the lean amine which is fed back to the absorber. So, this absorber regenerator are taken in pair to do this particular process, and for the regeneration, as I said, that low pressure steam is taken, and this low pressure may be obtained from this particular steam which is obtained after the catalytic reactor, Claus reactor. So, this is how we carry out the overall process. And lastly, we come to the scavengers. These scavengers are similar to the ones which we learnt in another separate lecture on the acid gas removal. In that particular lecture, I have given a detail of the scavenger operation and how to select the scavengers. So, I am not going into any of the details of that scavenging operation. Here simply I am putting the salient features that it is used for the acid gas removal too, and it is removal of the small quantity of sulfur about 80 kg per day or less, and these scavengers, because they are reacting chemically with the H2S, so they cannot be recovered. So, that is only once through, and that is why they are confined whenever we have small amount of H2S. So, these are the references which may be consulted for more detail. Thank you.